So my step now looks like e to the power y, I keep that here, divide by 2 plus e to the power y, that bracket. dy stays there. Separation of the variables, please. X is there. Move e to the x to the denominator, becomes e to the x there. And dx comes back. Okay. So we got all y and dy, all x's and dx. Separation is done. Now we will be able to integrate them. So it's the integration on both sides there. This is guessing style again, right? If you differentiate the denominator, you get numerator. So it's actually natural log e to the power y plus 2 is the answer for that, right? Equals to this one, dangerous, integrate x times e to the minus x, please. You got to know all these rules. As I said, this is integration by parts, isn't it? So let's integrate this by parts, right? So we differentiate the x, we integrate that. So uv, so I will write that there. You all know these methods. uv minus integrate u dash v. That's what I have. So uv is x and v is the differentiation of that. So it's a minus e to the minus x. Minus e to the minus x. Done. Minus integrate u dash is actually 1 times v is minus e to the minus x. So we can take the minus, make it a plus. X e to the minus x plus integration of e to the minus x is again minus x, so no, minus e to the minus x, correct? Integration, please. So the final step here is actually minus x e to the minus x minus e to the minus x. That's what we have. That's integration by parts of that sum there. Left hand side we know is ln e to the power y plus 2. Then we can make e to the y plus 2 as subject, and this becomes, see, if I say e to the y plus 2, I keep there, equals to transfer the ln, that should be e to the power this. Okay. Then you can actually split if you want to, or just leave it like that, e to the power blah blah blah, then you say minus 2. Okay, pretty easy sums they are. Just be careful how you integrate by parts there. All right. Now the next question, well, you try and solve the rest of the part there, right? Just the method is very important. The question 12 is there 1 plus cos 2y and cos x. All x's are, the y's are in this bracket. Can we say 1 over 1 plus cos 2y? A very interesting question looks like dy is equals to cos x dx. Now, wow, this looks very interesting. 1 over 1 plus cos 2y. What do we do? You know the double angles, if you actually see, I will take you through another page there. You might have done these questions. Just want to take you through if you forgot about it. We know cos 2 theta, I say cos square theta is 2, I say cos 2 theta, guys, right, is equals to 2 cos square theta minus 1. If you make cos square theta subject, that's supposed to be a half cos 2 theta plus half. So we have 1 plus cos 2 theta there, 2x, right? If I divide by 2, that can be changed to cos square x. Then we will be able to integrate this. So that's very, very important method. Very nice question, really. See how we do this slowly, right? So I'm going to divide this by 2 there. Divide by 2 here. Watch. So it's a half plus half cos 2y. When I do that here, numerator also I have to divide by 2. So there is a half. So my question now becomes half on top divided by the denominator is actually cos square theta or cos square y and dy. That's it, okay, is equals to integrate cos x. Sorry, we need to integrate that. We did not integrate yet, okay, that's a dx. Half, it's 1 over 2, so that's 1 over 2, and that's over 1. So what's 1 over cos square means? That's a sec square. So it's a sec square y, right, is equals to integration of cos is a sine, we know. We didn't integrate this yet, okay, that's a sine x plus c. Let's integrate sec square y, we know, is a tan y. That's nice. It's a half tan y is equals to sine x plus c. Keep the tan y here, equals to 2 sine x plus 2c. You can change that by another letter a. Then if you want, well, you can leave the answer like this or make y subject. It will be tan inverse that. Okay, just be careful how we did this. The method I want you to follow. So we divide by 2 in the numerator and denominator to make denominator look like cos square. So it's a 1 over cos square will become sec square. The half will stay as half. Integration of sec square, we know, is tan y. That's it. So 12 questions are done up to now, right? 12 sums done. These are the different types of general solutions that you need to know, okay? Basic algebra and trigs and e to the power x and ln x, they all get involved. Now the next part is based on finding the particular solution. You will be given the initial value, like when x equals to 0, t is 5. So we substitute them and find that c or that k. So that's the next part now. All right. So the next section is on finding the particular solutions. Method is exactly same, but we use that extra information given to us, which is called initial conditions. Some textbooks call it as boundary condition. Yeah, boundary conditions or values. That's what they call some textbooks. Dy over dx is sin x cos square x. That's a very nice question. 1 dy equals to sin x cos square x dx. So we integrate on both sides now, right? This is y equals to, that's the cos cube, right? Guessing style. So that's a 1/3 cos cube 3 cos square. So it's a 1/3 with a minus, I suppose, cos cube x. That's the answer for that guessing style, please. And plus c, right? That's the general solution. If we use this given information, the pi over 3 and 0, pi over 3 should be the x value, 0 is the y value. Substitute there, you should get c. So y equals to 0, that's a minus 1/3, pi over 3 is 60, cos 60 is half, half cube is an eighth. All right, so that's an eighth plus c. So the value of c is actually 1 over 24, that comes to the right hand side. Okay, we found the value of c by using the initial condition. Now our aim is to substitute this back in there so we have the particular solution, right? So the answer should be y is equals to minus 1/3 cos cube x plus 1 over 24. So we can leave it like that. Okay, that's the first question. Not bad. I think you understood that, right? We integrate on both sides, done, but that extra bit, we use that initial values that they gave and found c. Second question is here. Try please. That's 1 minus x square dy over dx is equals to this. Initial condition, x and y are there, right? That's pretty straightforward, but dangerous. I think we need to make y subject here. So we get x plus 1. Nice, okay. So we transfer the y to the left hand side. So watch how it is done. You all know now, you practice lots of sums. It's 1 over y dy is equals to, I keep the x plus 1 on top. Denominator is 1 minus x squared, nicely factorized. Dy is there. Then we can integrate on both sides now. That's actually 1 plus x, 1 minus x, right? So the 1 plus x is cancelled. I'm left with 1 over 1 minus x, right? I don't want to waste more time on that. So that's a natural log y is equals to, by the way, okay, I'll go back there, right? That's 1 over 1 minus x, which is natural log 1 minus x. But please understand, differentiate this, you get a minus 1. Divide by minus 1 means that is minus. Plus k, okay? Yes, some students ask me this question, sir, why should we write the plus k or plus c on one side only, right? It's actually on both sides you are integrating, but this c all together is just 1. So either you write on the left hand side or you write on the right hand side, okay? That's natural log y is equals to this. Now we stop there. We don't go and write the general solution as y equals to. Let's substitute these values into the question and see what we get here. X is a half, so let's write a half there, and y is a 6. So that's natural log 6 there is equals to minus ln 1 minus a half, which is a half, okay, plus k. Then this is minus ln, half is 2 to the minus 1, watch, right, plus k. And simplify a little bit further, use all the logs rules that you know. Minus times a minus, that goes to the top, becomes a plus. So that's ln 2 plus k. Left hand side is ln 6. And k is equals to ln 6 minus ln 2. Don't say ln 4, all right? That's log a minus log b. So log a divided by b equals to k, which is natural log 3. So once you get this k value as natural log 3, all that we do now is go back to that step and substitute that as ln 3, and little bit of further simplification is needed, all right? So let's just do one question, because this is the first type that we have done. Let me go a little bit back, right? I'm taking that equation now and I substitute ln 3 there, right? So I have natural log, watch there, it's ln y is equals to minus ln 1 minus x and plus natural log 3, right? Simplifications can be done, right? This is actually log a minus log b, so it's log a divided by b, ln, nice bracket there, 3 on top, 1 minus x at the bottom, log a divided by b. Left hand side is ln y. Because both sides are ln, either you transfer ln or simply cancel them, we get y is equals to 3 divided by 1 minus x. Okay, so that should be the final particular solution with respect to the given initial condition of that differential equation. Okay, this simplification is very important for you to do that. Let's try. We have another one here, which is xy dy over dx and y square minus 9. Let's transfer that to the left hand side. It's y divided by y square minus 9 to the power half, all right? That's a root there. Dy is equals to, transfer the x, so it should be 1 over x dx. Pretty nice. So we, we came up to that stage. Now our aim is to integrate on both sides. Is that a guessing method? I mean, if you differentiate this, will you get that? No. Take this to the top because you have half there. This is a method that we all learned called fx f dash x times fx to the power, say, n. You know, that kind of stuff. So I will solve that here for you. Watch that. So y divided by y squared. So can I take that to the top? Y squared minus 9 to the power half. So we need to try and guess. Say, let the integral there is actually y square minus 9 to the power, it's a minus half, please, when you take that to the top. So minus half plus 1 is a half, and we differentiate this now. We get half times y square minus 9 to the power half minus 1 minus a half multiplied by chain rule, which is 2y. What basically happened, the 2 and the 2 cancels out. You are left with y square minus 9 to the power minus half and then a y, which is exactly same as y divided by square root of y square minus 9, right? So that was the question. So the answer should have been that, y squared minus 9 to the half. Okay, so all these methods you got to know before we start this topic. So the answer for this is in fact y square minus 9 to the power half. That's what we have there. Is equal to, that's a natural log x plus c, right? Then this is the general solution before making y subject. Let's substitute the initial values that we got, right? So this is the x value and that's the y value, please. So now x and y values, very important, right? Y is a 5, so 5 square, 25 minus 9, 16. 16 to the half is a 4, equals to natural log x is e to the power 4 and plus c. So this is a nice one. ln e to the 4 is actually 4 plus c. So we got c is equals to 0 in fact. So that c value or k value is 0. So we go back to this equation there and substitute c as 0. But we still have to solve for y. So don't forget that, right? So I'm copying that equation now. See what we get. So we have y square minus 9 under the root is equals to ln x. C is gone because that's 0. I transfer the square, so we know how to solve these simple ones now. Ln x whole square, please. Don't write ln x square here. That's a whole square. After that, move the 9, it will be a plus 9, right? And then move the square, it should be a square root, right? So y is equals to ln x whole square plus 9 under the root. That's the particular solution of the equation that we got. Okay, we are still solving the first order differential equations, please. Now these are, I'm now moving to the examination sums, right? Because we did so many sums of different types, let's see how the examiners actually give these sums and ask you to solve. So one exam question there. 1 plus 2x whole square dy over dx is this. All right, so let's take the sine square y here. Right, let's do slowly. Sine square y dy will stay there equals to x divided by 1 plus 2x whole square and dx. Okay, we can do in many ways. Okay, integrate left hand side sine square theta integration, guys. We got to know, write this as a half minus half cos 2 theta, right? 2y. Okay, then we integrate that with respect to y. Right hand side, you can do this by substitution method or different types. I think I'll do by substitution method here. Watch, I'm doing this now. Okay, so u equals 2, let's take as 1 plus x, 1 plus 2x. Let's write du over dx is equals to 2 and dx will be du divided by 2. You all know the integration by substitution. And now I need to just make x subject. So x is equals to, from there, u minus 1 divided by 2. So it's a u minus 1 divided by 2. These are the values I'm going to substitute. Please understand, sorry for the mess, but I didn't integrate this yet. We are doing that only. So substitute them, integrate. X is a u minus 1 divided by 2. Done. Denominator is a u square, so that's a u square. Dx is du divided by 2. So that's a du over 2. I would like to take that 2 out, which is a quarter. Then you integrate this. I think split is the best way. U over u square minus 1 over u square. Du there and bracket. So we can integrate this now. A quarter, that's 1 over u, which is a natural log u, and minus, that's u to the minus 2, right? So minus 1 divided by minus 1, that's a plus. It's actually 1 over u. That's what you get, right? That is the integration of the right hand side. Left hand side integration we haven't done yet. We are running short of space, but I will do that in the same green ink at the bottom here. Watch. Half y and minus a quarter sine 2y, right? So that's actually half y minus a quarter sine 2y. That's what we get on the left hand side. Right hand side is this. 1 quarter inside the bracket ln u plus 1 over u. Guys, that's the general solution. We need to say plus c. All right, very important. Then the initial condition I got here is 0 and pi over 4. So 0 is the x value, pi over 4 is a 45 degrees. Nice one. Substitute them, see what do we get. Also here we need to write u as 2x plus 1 that we chose, right? So we can do that. Right. Initial conditions. Now half y is the angle. So half and y is pi over 4. Watch. Minus a quarter. Sine 2y is actually sine pi over 2. Because y is pi over 4. Equals to 1 quarter inside the bracket natural log u. U is, u was, watch there, it was 2x plus 1, right? And we substitute x as 0, right? So we get, this is 2x plus 1 there. So that's 0, natural log 1, which will be 0, right? Plus that's 1 over 1 if you put x as 0, which is a 1. Done, plus c. Beautiful, right? We got that. This whole thing is just a quarter, and c is equals to, transfer that to the left hand side, sine pi over 2, please. Sine 90 is 1, right? So minus a quarter is minus 2 quarters, which is a half. So minus a half, this is actually pi over 8. Guys, listen, that, right, watch out please, that's the value of c. So we go to this equation again and then substitute the value of c as pi over 8 minus 2, then you can leave it like that in my opinion. There is no way you can make y subject in these two. Alright, so that's one of the examination sums based on the substitution. That's it. We have one more. Various exam boards, not just one. Right, so that's e to the x, dy over dx, x over sine 2y. See what happens. Sine 2y, left side, right? E to the x, right side. All right. So that's going to be sine 2y dy equals to x over e to the x, which is e to the minus x, and dx. Okay, we just now did one question based on that. Integrate on both sides now. Sine theta integration is minus cos theta, which is 2y, and then divide by 2, reverse of the chain rule, equals to, the answer for this by integration by parts we have already done. It should be minus x e to the minus x minus e to the minus x and plus k. That's what you get if you do by integration by parts, please. Initial condition given to me as 0 and pi over 4. So that's the y value, that's the x value. Pi over 4 is a 45, please. So it's a minus half cos 2 pi over 4 is pi over 2. That's 90. Cos 90 is 0, right? And x value is